So today, if you're like me, you've been very surprised over the past year at the developments in artificial intelligence. I've worked in this field for decades, but I'm very surprised. And so I thought it would be interesting in this talk to very briefly, quickly summarize where we are with systems, generative AI systems, but then spend most of the talk looking at some of the trends that are beginning to emerge that I believe are going to determine where this technology goes over the coming years. So that's the goal of the talk. So let's start by looking at GPT-4 as an example. I guess this is a hand-raising conference. How many people have experience with ChatGPT? Excellent.
Everyone.
Everyone. I'm sure online the same holds. So we're among the many millions of people who've tried this out. And so as you know, ChatGPT, which is based on the underlying model called GPT-4, is a conversational AI system. Under there is a big neural network with hundreds of billions, we think, of numerical parameters. It's been trained in a very interesting way that doesn't involve very much human input. It's trained to predict the next word in a sequence of words. The good news about that training task is that from the web, we can get easily several trillion examples of snippets of text followed by the next word. So part of the breakthrough here really comes from thinking of training the system this way. It leads to a number of very surprising capabilities, which you've seen some of those if you've played with ChatGPT. And of course, the system is still imperfect. Famously, it's known to hallucinate pseudo-facts, which aren't really true, but it will output those with the same tone of confidence that it uses for facts that are indeed true. So that's kind of where we are. Let's take a look at a couple of quick examples to calibrate. Here's an example where the prompt to GPT-4 is, can you write a proof that there are infinitely many prime numbers with every line that rhymes? And indeed, here is a poem written by GPT-4, which is also a proof that there are infinitely many primes. So this is the kind of thing that you can have it do. This week, well, this month, I should say, OpenAI released a version of ChatGPT that accepts images as input. So on Monday, I took this photograph of 4 objects on my desk, and I asked ChatGPT, how can I stack these 4 objects stably? And it gave me instructions, which I followed, and sure enough, it was right. That's the stacking of the 4 objects. So even though it's trained primarily on text, it has this kind of surprising ability to answer questions like this, which we think would involve reasoning about physical properties of objects. Here's another example. I know there's a session coming up, which I'm looking forward to, on AI applied to education. I'm interested in that topic too, so I gave one of the math word problems that high school students get. I gave that to ChatGPT. Suppose Mary drives from point A to point B at 100 kilometers an hour, while Bill drives from B to A at only 50 kilometers per hour. Will their paths cross, and if yes, then where? And GPT answers this question correctly, gives the reasoning, says they'll meet at a point 2/3 the way because Mary is driving faster. So that's kind of interesting. More interesting is that next I said, well, suppose a student answers this question incorrectly and says they will meet halfway between points A and B. What would be a good hint to give the student. And as you can see on the bottom, it says, you could say something like this. Remember, they're not driving at the same speed, so they won't meet halfway. Think about who's driving faster and how that affects where they will meet. The faster driver will cover more distance in the same amount of time. I think that's a fantastic hint. And it illustrates a capability, another surprising capability of GPT, to not only answer the question, the math question, but to do the kind of metacognition that's needed in order to understand what would be a good hint that would not give away the answer. So one more piece of this, if you're interested in AI applied to education, one of the big problems with online education is motivating students and not having them drop out. I have a granddaughter who's a big fan of Taylor Swift. So I said, please rewrite this advice in the style of a pop singer like Taylor Swift. And it rewrote the hint as a song, a Taylor Swift style song, where the chorus is the hint. The chorus says, you gotta focus on the distance they travel before they meet and their paths unravel. Merry speed is faster, that's a fact. So halfway between A and B is not where they'll land. So, and then you do another verse and you come back to the chorus. So, okay, examples of what GPT can do. GPT, of course, generates text as output. We also have other systems like DALL-E, Midjourney, Stable Diffusion that can take as input text descriptions of images and output images that satisfy those properties. Like the one on the left, I input a falcon landing on a camel in an oasis. The one on the right, I wrote an art piece depicting a feeling of regret in a winter setting with a focus on snow and frozen landscapes. So these are some of the capabilities. All right, now, enough said about that. We're here to talk about what's going to happen next. And I, of course, have to point out that I don't know what's going to happen next. Nobody can predict the future. But we have to try. I think it's crazy to just give up on thinking about the future, even though you might be wrong. And so I'm going to go very quickly through 5 different trends that I see in this field. Trend number 1, very interesting trend over the past year. Large language models like ChatGPT can now call traditional software as plugins. For example, ChatGPT, which famously could not originally multiply big numbers successfully, now can call out to a calculator. It can call out to a search engine. It can call out to Wolfram Alpha, which is a large knowledge base itself. ChatGPT now has roughly 1,000 different plugins. This is important as a trend because what this is doing is it's making it very quick and easy for these language models to increase their competence, their capabilities, by simply allowing them the ability to call out to other programs. So for example, now, if I ask ChatGPT, how much is 1,324,000 times 38, it gives me the answer. And it says, here as you can see, it says it used Wolfram Alpha. And it says, would you like more details? If I say yes, then it gives me the detail. So now ChatGPT, when you use it, there are over 1,000 possible plugins that range from travel planners like Kayak to OpenTable, a restaurant reservation system, and others. Okay, so that's trend number 1. Again, the significance of this is that it's a way of exploding the capabilities of ChatGPT, not by building different AI, but simply by allowing it to interface to other code. Trend 2 is kind of the flip of that. If trend 1 is that now large language models can call other software, trend 2 is we're beginning to see software development frameworks that allow developing code which uses LLMs as subroutines. So for example, we have systems like LangChain, Microsoft Semantic Kernel, AutoGPT, which is open source Python code, that are really software development frameworks that make it easy for you to write standard traditional software, but call large language models as subroutines. To give one quick example, I mentioned I'm interested in AI applied to education. My students have recently developed a tutoring system whereby humans try to learn material by teaching a student bot. So it's sort of the hypothesis is that people learn well if they can teach material. And the student bot that they teach is itself a GPT-4 based system. Furthermore, as the human is trying to teach this student bot, if they get stuck, there's a second bot called the professor bot, which the human can turn to for help. So the details of that are not so important, but what is important is it's just one simple example of what I mean by developing larger software systems that use multiple instances of large language models as subroutines, literally. Okay, now, what's the significance of this trend again is that in this case, I think this is really the beginning of an entirely new programming paradigm, a new software development paradigm, where we can combine the kind of mathematical precise statements of typical programming languages with much more informal natural language-based phrasings of what we want the LLM subroutine to do. And the data that's passed back and forth among these components of the software is now some mix of that precise mathematical data structure and natural language emitted by the subroutine. Okay, trend 3, personal large language models. If you and I both use ChatGPT, we're pretty much seeing the same agent. That's going to change. One piece of evidence for this is a month or two ago, Google released an experimental version of Bard. Bard is their version of ChatGPT. In this experimental version, you can give it access to your Gmail and your Google Docs. And then you can ask it to discuss that. That's very personal. And if you use Gmail, you know that there's a lot of information about you, your work life, your relationships in that Gmail. So for example, I used the system recently. I said, summarize my recent emails regarding my upcoming presentation at the US Patent and Trademark Office. And it said, I think you can, maybe not in the back, read this, so I'll just give you the skim. Its response is, you received an email from Ram Kanduru regarding your upcoming presentation at the US Patent Office. He shared the link to the Google Drive where all the content for the lecture series is stored and asked you to confirm your lecture date by entering your initials in column F of the scheduling spreadsheet. So it's giving me my to-do items from this email. He also mentioned that all the lectures to date have been very well received, et cetera, et cetera. So this system, actually, I've played with it now quite a bit, does a remarkable job at summarizing the to-do items and the content of the emails that are relevant, in this case, to this topic I gave it. It's still kind of clunky. Surprisingly, I think its weakest current point is that it doesn't do all that good a job figuring out which emails out of the thousands in there are the ones to read for this particular task. But this is Google. I got to figure they're going to solve that problem of finding the right emails. So again, here's a trend. It's important because I think there are huge potential benefits to us users if our version of ChatGPT or Bard or whatever really is knowledgeable about our workday lives and our personal lives. Makes a much more useful agent. It also raises some interesting questions about privacy, for example, and about whether anybody will be able to compete with Google and Microsoft, which have the two most widely used email systems, Gmail and Outlook. If you're a startup trying to get into this area, there might be an unassailable advantage to those big providers of email that make it hard for you to compete. Okay, trend 4, multimodal foundational models. What I mean by that is that ChatGPT works on text only, pretty much, but now there are models under development, like Google's Gemini, which they've announced they're developing, but they haven't yet released it, and they say 2024 is the likely time period. But when Google announced Gemini, they said it's going to be trained from the bottom up on multimodal data, including images, text, voice, sounds. And so if you think of what came out of the work to train a system just to predict the next word in text, ask yourself what's going to come out of a system that's trained to predict the next image, sound, voice, expression, etc. Sounds very interesting. We don't know exactly where this is going to lead us, but for example, I could imagine a future with these kind of systems where when I'm cooking dinner in the kitchen, I put my phone on video mode, and not only does Google give me the recipe, but it's watching me and it says, Tom, it's time to turn the egg over now, or whatever. So it just, let your thinking go a little bit creative about how these fit together. Okay, final trend. I think this is the biggest one, open source. So in November last year, when ChatGPT was released, the conventional wisdom was there will be a dozen or fewer large organizations that can afford the $100 million plus that it costs to train a state-of-the-art language model. The rest of us will use them over the cloud. That conventional wisdom has been severely questioned now by an open source movement, where instead of a sequence of models that get bigger and better, recently, in 2023, you can see a lot of work on models that are 1% or smaller, less than 1% of the size of the biggest models out there. And this has led to a lot of surprises. For example, Microsoft's Phi 1.5, which is one of these on here, has only 1.3 billion models, or 1.3 billion parameters, but it's trained to, and it's only trained to produce code, but its capability is second only to GPT-4, and it outperforms many of the models that are roughly 100 times its size. So where this trend will go remains to be seen, but it's a very important trend because this is the big wild card that will determine whether we live in a future where there are a dozen or 2 dozen large organizations that hold the keys to AI, or whether we have thousands, hundreds of thousands of much smaller models circulating around the world. Implications of that include all kinds of things from commercial application to government control. It's hard to control open source movements. Okay, so let me stop there. There are even more possibilities. But I think what I want to, if there's a take-home message, it's we really are at a watershed moment for AI. Progress is, if anything, going to accelerate, not slow down. We're going to see this kind of AI integrated in all kinds of software, and should be an exciting future. Thank you.
Tom Mitchell.